Okay, polar. BC Calculus, the last example. Woo! It says find the area inside both the circle r equals 9 cosine of theta and r equals 9 sine of theta. Well, always do a little rough sketch. 9 cosine theta, that's just a circle with a radius of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, let's see. Yes. And then a 9 sine of theta. 1, 2, 3, 4, 5, 6, 7, 8, 9. I am not an artist at all. So essentially, I want this piece in here. Now, if you'll notice, this thing splits. So I need to find out where it splits. So to find out where it splits, I set these equal, because that's where they intersect. I need my intersection point. 5 by 9. Where does cosine equal sine? Or you could take it a step farther and say, whoops, where does tan equal 1? Well, same thing. Where are sine and cosine the same? Well, at pi over 4. Okay, so this is pi over 4. So this thing splits apart at pi over 4. Okay, and then it goes back to 0. If I'm looking at this curve, where does it go back to 0? Let's show that. I don't want you to wonder. And I'm doing the 9. This is the cosine of theta. At 0, cosine of 0 is 1 times 9 is 9. So here is at 0. 0. And then at pi over 2, cosine of pi over 2 is 0. So it's back at 0. So it's here. So this little value here is pi over 2. Okay? So if you notice, this thing splits. Just like when you're finding area under curves and you're doing volume, it's where does the curve split? If you think about your radius, on this side, wait, like that, what is it hitting? Okay? From 0 to pi over 4, it's hitting this circle. This circle is 9 sine of theta. So it's 1/2 9 sine of theta squared. Okay? Plus, all of a sudden you're on the other side now. From pi over 4 back to pi over 2, what are you hitting? What is your radius attaching to? Well, from pi over 2, or 4, 4, 4, to pi over 2, if you can see this good, 1/2, it's going to the 9 cosine of theta. It's hitting this graph on this part, and it's hitting this graph on this part. It's like a leaf. So 9 cosine of theta squared d theta. And that gives you 11.559 when you stick that in your calculator. Let me double check. Yes, that is perfect. Okay. That was the end of the polar, the area. I may end up having to go back and put some more videos on there, just randomly teaching you how to graph them and talking about the different derivatives and the tangent lines and tangent set a point. I'll let you know if I need you to watch those.